Okay, so we are going to learn probability. Before learning probability, we need to know a wording called set. Set is actually talking about a language or a kind of notations to present different kinds of things. One of the application is to present or to describe something about the probability. So actually in the probability we have a kind of wording or kind of concept called sample space. Sorry. And for the set notations, actually we have a multiple kinds of concepts. First one is event. Actually, in a sample space, we have multiple events that can be defined. Now, in set, we have different kinds of notations. For example, the union. Another notation is intersection. And also another one is called the complement to representing the relationships between different kinds of events. So I will illustrate it using an example. Now let's say we have a situations of rolling a die. For rolling a die, actually we have 6 consequences. Because there are 6 numbers right there. 1, 2, 3, 4, 5, 6. Okay, so here, in these situations, we have 6 possible outcomes when you are rolling a die. So actually, you have 6 possibilities right there, and for these 6 possibilities, these kinds of domain, these kinds of area, we call it sample space. Now let me define this sample space using a notations called S. Now here, the number of choices, let me erase the 6 first. So the number of choices in this sample space S is actually equal to 6 because you have 1, 2, 3, 4, 5, 6. These 6 possibilities. Now here, if we kind of defining a event that is combining these 3 outcomes 2, 4, 6, obviously you can see that this is a even number. Even number, let me define the even number outcome is equal to E. Okay, so this is a kind of a event, and we define this event is equal to E. Now here, the number of choices for when you are rolling a die, the number of choices that you can get a event, get a even number is actually equal to 3 because you have 2, 4, 6. These 3 outcomes. Okay, finally, so why do we need to? What's the relationship between this kind of sample space, events? The relationship with the probability is this. Now let's say P. P means that's the probability of getting a result with an even number. So this is the notations for the probability. Let me write that. Probability of getting even number is actually equal to the number of choice favorable choice over total number of choice. I think you should have learned it in secondary 3. So here in this situation, so this is the fundamental of the probability. Okay, if we change the formula, the meaning is the same by writing this. So getting a even number probability is actually equal to the number of choices of getting a even number over the number of choices of getting in this sample space, which is equal to 3 over 6. That will be equal to 1 over 2. Now, this is quite obvious, but later on, when we are talking about some very difficult probability, we always need to know the sample space. The meaning of sample space is actually trying to think of all possibilities. That is very crucial when you are doing a probability, is to count all the possibilities. Sometimes you miss some sort of possibilities. So that's why when you are doing the denominator, you miss something. For the numerator, we always talking about some events, but later on we have a multiple events, and these events will add them together or multiplying together. So when we should add, when we should multiply, we can utilize these kinds of set notations to help us to understand more. Now, apart from that, I think you should already learn the values of probability is actually in between 0 and 1 inclusive. 0 meaning that the event is impossible to be occur. While if you calculate the probability is equal to 1, meaning that kind of event is certain to happen. Okay, and also in order to understand the relationship between sample space and event, we have a very famous diagram, so-called sorry, how come it cannot be detected? So-called the Venn diagram. Okay, it's actually talking about a diagram with a rectangle, and this rectangle is the sample space. Oops, spelling wrong. Okay, so in the diagram, in the sample space, we can have multiple events. Let's say we have 2 events right here. Normally we represent it by circle. Let's say this is equal to A. And the other one is actually equal to B. Okay, so you can see that there is an overlapping region right here. That means that A and B can occur at the same time. So previously I talked about these three set notations that is called union. Now union, let me take an example, A union B. A union B is talking about A or B. So for simplicity, this union notation is talking about OR. Okay, so let me draw another Venn diagram. So this is A and this is B. So graphically, if we want to know the meaning of A or B, is actually equal to this area. Okay, and for A intersect B, then you will know this is actually equal to n. So again, for the Venn diagram, I don't want to write A and B anymore. So for these situations, n is both of them should happen at the same time. So that is talking about the overlapping region. Finally, this notations, complement. Complement is actually the meaning of not A. Okay, so let's say there is a right here. So not A is outside the region of the A. Okay, so finally you can see that in actually set has many notations. For example, this one, that one, etc., etc., etc. I think they are not so important in core mathematics, so I will not mention that. I think only these three, union, intersect, and complement, is important in core math probability. So that's about the set notations and the probability before we really calculate the probability.